learning target, I can write arithmetic sequences from a pattern. You may recognize the word and think that the word spells arithmetic, and it does spell arithmetic. However, with the sequences, instead of using the pronunciation of arithmetic, we use the pronunciation of arithmetic. And an arithmetic sequence is a pattern but unlike the geometric sequence, this pattern is made of addition or subtraction. So each next term has either had something added or subtracted to the term previous to make it. And that something is called a common difference, and it must be the same. The common difference must be the same for the whole pattern. So here, like geometric sequences, we also have a formula to help us identify specific terms in a pattern. This may look intimidating, but once it's broken down, it really is not that hard to follow. Just like geometric sequences, with an arithmetic sequence, the A to the N is the pattern that you're looking for, the term in the pattern that you're looking for. The A sub 1 is the first term in the pattern. And you can remember that because it is a sub 1 for first. Okay, 1 for first. The D stands for common difference. And that is the value that is being added or subtracted to make your pattern. And just like with a geometric sequence, N is the term number. So here's our first pattern to look at. We see we have 3, 5, 7, 9, 11, 13, and it continues. We're being asked to write a formula for the pattern and find the 20th term. So first of all, we need to determine, is this a pattern of either addition or subtraction? As I analyze my numbers, I know that if I add 2 to 3, I get 5. If I add 2 to 5, I get 7. If I add 2 to 7, I get 9. If I add 2 to 9, I get 11. And 2 to 11, I do get 13. So yes, I can safely say this is an arithmetic sequence with the common difference as a positive 2. So the formula that we looked at was A sub the term number we want equals the first term plus the common difference times N, the term number, minus 1. So let's see if we can substitute values in and find the 20th term. So we are looking for A sub 20. And we need that to equal the first term first term is 3, plus the common difference, well, we just determined the common difference is 2, times n is the term number, 20, minus 1. We're going to use our order of operations to simplify. 3 plus 2 times 19, 3 plus 38. So the 20th term in this pattern is 41. Let's look at our next pattern. Again, we always have to check to make sure it is an addition or subtraction pattern in order for it to be an arithmetic sequence. So we have 15 to 9, 9 to 3. Well, I know my numbers are getting smaller. So 15 minus 6 is 9. 9 minus 6 is 3. 3 minus 6 is negative 3. Oh, I see where this is going. Negative 3 minus 6 is negative 9. And negative 9 minus 6 is negative 15. So my common difference this time is negative 6. So my D is equal to negative 6. So let's look at filling in the proper values for my formula. I know that I want the 37th term, so A sub 37 is what I'm looking for, and that needs to equal the first term, which is 15, plus the common difference, which is a negative 6, times n, the term number 37, minus 1. I'm going to use my order of operations to find the 37th term. I'm also going to simplify that plus minus. I know that if I add a negative, I'm actually just subtracting. So A to the 37th term equals 15 minus 6 times 37 minus 1 is 36. Now, using my ACT approved calculator, I know that this is 15 minus 216, and that would be a negative 201. The 37th term of this arithmetic sequence would be negative 201. I need to find the 100th term, and this time I'm actually given the first term and I'm given the common difference. So we're looking for the 100th term, okay? So A sub 100 has to equal 4 plus the common difference of 10 times the term 100 minus 1. So even though I wasn't given a pattern to check, I know by the information I was given that this is an arithmetic sequence, and I can use the formula. So the 100th term is equal to 4 plus 10 times 99. Using order of operations, 4 plus 990. My 100th term is 994. Same type of problem. I'm given in the first term a common difference and a term number. So this time they want me to find the term number would be 31. So we have A at the 31st term equals negative 3 plus negative 2 times 31 31 minus 1. Again, I'm not only going to use order of operations to simplify, I'm also going to use my knowledge that when I'm adding a negative number, I'm actually subtracting. So this is equal to negative 3 minus 2 times 30, which equals negative 3 minus 60, which is negative 63. One last problem for you, and this problem, we want to set up the formula for the pattern, but we're not going to be given a term. So we have a to the first is equal to 8. We have d is equal to 7. And we're not given a term number. So we don't know what n is. N is equal any term. When we set this up, this allows us to write the formula for any term when the first term is 8 and our common difference is 7. So when I set up the formula, I know it's the a to the nth term is equal to 8 plus 7 times n minus 1. And I do need to simplify. My a sub n, my a to the nth term, is equal to 8 plus, I have to distribute here. So 7 times n and 7 times negative 1. And now I can simplify. My a to the nth term is equal to 8 minus 7 is 1 plus 7n. So I have found the formula for any pattern that is arithmetic, where the first term is 8 and the common difference is 7. And that will let me find any term I need to find.